In this lesson, we'll be learning how to name cycloalkanes. Cycloalkanes are alkanes where the carbon atoms form a closed ring structure. They have a general molecular formula of CnH2n. Cycloalkanes and alkenes of the same carbon atoms are isomers, since they have the same molecular formula but differ in their structure. Now, let's highlight the steps on how to name cycloalkanes. Step 1. Determine the number of carbon atoms in the ring and find the alkane that corresponds to that number. Then attach the prefix cyclo to it. Now, taking this for an example, the first thing we need to do is to determine the number of carbon atoms in the ring. In this case, we have 1, 2, 3. So we have 3 carbon atoms in this ring. Each of these edges represents a carbon atom. Now, which alkane corresponds to that number? An alkane with 3 carbon atoms is called propane. Attaching the prefix cyclo, we have cyclopropane. So that is cyclopropane. Let's also look at this. Here we have 1, 2, 3, 4. 4 carbon atoms. An alkane with 4 carbon atoms is butane. Attaching the prefix cyclo, that becomes cyclobutane. So this is cyclobutane. Let's also look at this. Here we have 1, 2, 3, 4, 5. An alkane with 5 carbon atoms is pentane. Attaching the prefix cyclo, this becomes cyclopentane. So this is cyclopentane. We also have cyclohexane, cycloheptane, cyclooctane, and so on. Step 2. Number the ring in clockwise and anti-clockwise direction. Then choose the numbering that gives the substituent the lowest possible number. So we number in clockwise direction and then in anti-clockwise direction. We then choose the numbering that gives the substituent the lowest possible number. Step 3. Combine the substituent name and their location with the parent chain name to give the IUPAC name. Before we take some examples, here are some things you should note. 1. If there is only one substituent on the ring, then that substituent is automatically on carbon 1 position and we do not need to assign a number to it. For example, instead of writing 1-methyl-cyclobutane, we just write it as methyl-cyclobutane. 2. If there are more than one substituent on the ring, then the substituent that comes first alphabetically is assigned the number 1 position. 3. If the alkyl has more carbon atoms than the ring, the alkyl becomes the parent chain while the ring becomes the substituent. Before we continue, if you find this lesson interesting, do well to subscribe and turn on the notification button so you get notified whenever we drop a new video. Now, let's take this example. Here we have 1, 2, 3, 4. We have a 4 carbon ring. An alkane with 4 carbon atoms is butane. Attaching the prefix cyclo, this becomes cyclobutane. So the parent name is cyclobutane. Now let's identify the substituent. On this ring, there is only one substituent. And remember, when there is only one substituent on a ring, then that substituent is automatically on the carbon 1 position and we do not need to assign this number to it. So instead of writing this as 1-methyl-cyclobutane, we write it as methyl-cyclobutane. Now let's look at this. Here we have 1, 2, 3, 4, 5, 6. We have a 6 carbon ring. An alkane with 6 carbon atom is hexane. Attaching the prefix cyclo, this becomes cyclohexane. So the parent name is cyclohexane. Now let's identify the substituent and choose the numbering that will give this substituent the lowest possible number. Remember, we number in the clockwise and anti-clockwise direction, giving the substituent that comes first alphabetically the number 1 position. Here we have two substituents, bromine and methyl. Alphabetically, B comes before M, so we assign the carbon 1 position to bromine since it comes first alphabetically. Now that we have numbered this in the clockwise and anti-clockwise direction, let's determine which numbering would give this substituent the lowest possible number. If we number in the clockwise direction, our substituent will be on carbon 1 and 3. If we number in the anti-clockwise direction, our substituent will be on carbon 1 and 5. 1 plus 3 is 4. 1 plus 5 is 6. We know that 4 is lesser than 6. So we number in the clockwise direction. Now we have a bromine on carbon 1. So this will be 1 bromo. Then we have a methyl on carbon 3. This would be 3 methyl. So this is 1 bromo 3 methyl cyclohexane. 1 bromo 3 methyl cyclohexane. Remember, always write substituents alphabetically. As you can see here, we wrote the bromo before methyl. Now let's look at this. Here we have a 3 carbon ring. Attached to this ring is a continuous chain consisting of 1, 2, 3, 4, 5, 6. 6 carbon atoms. In this case, the alkyl has more carbon atoms than the ring. Now, in this situation, what do we say would happen? Remember, we said if the alkyl has more carbon atoms than the ring, then the alkyl becomes the parent name while the ring becomes the substituent. So we have a 6 carbon chain as the parent chain. An alkane with 6 carbon is called hexane. So the parent name would be hexane. Now we number the parent chain from the left to the right and then from the right to the left in order to give the substituent, which is the 3 carbon ring, the lowest possible number. So numbering from the left to the right, we have the substituent, which is the 3 carbon ring on carbon 4. Numbering from the right to the left, we have the substituent, which is the 3 carbon ring on carbon 3. Since 3 is less than 4, numbering from the right to the left would give this substituent the lowest possible number. So We number from the right to the left. So now that I've determined the position of the substituent, how do we name it? When the cycloalkane becomes a substituent, it is called a cycloalkyl. On this ring, there are 3 carbons. An alkyl with 3 carbon is propyl. Attaching the prefix cyclo, this becomes cyclopropyl. So this is 3-cyclopropylhexane. 3-cyclopropylhexane. Now try this and drop your answer in the comment section. Also, don't forget to subscribe.